Okay, so I want to move on. I want to move a little quicker. So I'm skipping around. I'm skipping to chapter 3, which is descriptive measures. Okay, so the first ones we're going to talk about are ones that you've probably been doing since maybe the 6th grade, and they're measures of central tendency or averages. Okay, and we have the mean, which you take all the values, you add them up and divide by the number of values. The median, which you put them in a line and go back and forth finding the middle value, and the mode, which is like the frequency. So you know these values. You've been working with them for a while. A couple of things. I want to make sure that you guys can compare. I want to make sure you can compare the mean and the median and know when to use what. Okay, so if the mean, it's taken by adding up all of the values. So if you have some outliers, so say your graph actually looks like something like this, okay, where most of the values are over here, but we have a few outliers, okay. The mean will be affected by those outliers, okay? It'll be pushed closer to the outliers over here, okay? So this is the mean. And the median will be less resistant, okay, to those outliers. So commonly, when there are, you have statistics and you have a couple of extremes, okay, that are skewing the mean, you're going to want to use the median, okay? The median is called a resistant measurement, meaning it's not sensitive to these extremes, okay? So when something is skewed a little bit, when something has extreme values, we want to use the median rather than the mean, okay? There is another thing we can do is we can trim the mean. We can have a trimmed mean, okay? And all that means is we cut out some percentage of the extremes, okay? Now the mode doesn't really show us the average, it just shows us the frequency, okay? So that's going to be used in other ways, all right? So let's go through a couple of examples. We have select an appropriate measure of central tendency to use. Okay, so the first one, A, a student takes 4 exams in his biology class. His grades are 88, 75, 95, and 100. Which measure of central tendency is the student likely to report? So this person is likely to report the mean, okay? That reflects all of the person's grades, even though they got that 75. That would be, you still have to take that extreme case into consideration, okay? B, the National Association of Realtors publishes data on the resale prices of U.S. homes. Which measure of central tendency is the most appropriate for resale prices? Okay. So there's some really, really big houses out there, and they have extreme price tags. So I would want to use the median, okay, which wouldn't be as influenced by these really large, expensive homes, okay? And C, the 2005 Boston Marathon had 2 categories of official finishers, male and female, of which there were 10,894 and 6,655 respectively. Which measure of central tendency should be used here? So I would use frequency here, or the mode, okay, to categorize male and female winners, finishers. This chapter also goes over summation notation. Okay, so you might be familiar with summation notation from another class, but it's used all over mathematics. Here they're going to talk about, they use it when they describe the sample mean, but this is summation notation. So say I had a couple of numbers here and I wanted to sum them. Okay, say I had 30 plus 20 plus 35, whatever, okay? We could, assign these values. Let's just say this is x, x sub 1, x sub 2, x sub 3, okay? And the notation that everyone knows, well, maybe not everyone, but if you're very familiar with a lot of math notation, this letter here is sigma, and it stands for summation, or you're summing a series of numbers. So in this case, you're summing all of the x values, x1, x2, x3 in order. So we're going to put the little index here as I. That sub is just stands in for whatever index number, okay, we're going to have. And then we're going to put that the index starts, well, did my pen die? Index starts at 1, right? That's our first number here. And it ends at, we could put a number here, we could put 3 here, or we could say that it ends at, let's put 3, because we only have 3 numbers here, okay? 3. So what this notation tells us to do is sum up all of the x's from x1 to x3. Okay, so this means x1 plus x2 plus x3. That's all it means, okay? And you're going to start seeing this a lot, especially in calculus. In Calc 2, this sigma notation is used all the time, and then you get even fancier. You get this kind of notation here, which is another sort of S-looking thing, okay? So this notation is used all the time. You might ask yourself, okay, is there one for multiplication? There is. It's just a very large pi, okay, with the same kind of stuff, but you don't see it as commonly, so I'll erase it. All right, so this is called sigma notation or summation notation, and you see it all the time. We're going to be using it here when we describe the sample mean, okay? So the sample mean, there are many sample means, okay? So in some of these studies, right, we can't take a census of the entire population, so we're going to have to take a sample mean if we wanted some kind of sample average, okay? And we're going to denote the sample mean by x with a bar on top of it, okay? And our sample size is going to be n. So this is the sample mean. This is sample size. Okay, and remember, there's only one population mean, but we're not going to really know it. We're going to know a sample mean. Remember, depending on your sample, there could be an infinite number of, maybe not an infinite number, but many different sample means. Hopefully they're similar, but there's only one population mean, and the sample mean is just going to be, they use sigma notation for it. They say, okay, x bar is equal to sigma xi, so that's all of our values, x1, x2, x3, however many values we have, and then the number of values. So it's just fancy notation of saying take the average of the sample. You already know how to do this. But they wanted to introduce that notation along with introducing the fact that there are many different sample means, and only one population mean. Okay, so since you're taking a sample, another guy could take another sample, and then those means could be slightly different. Okay, so that's something to make sure to note. All right.